how to calculate reaction forces on a simply supported beam. So a simply supported beam, you may remember, is a beam that is supported at 2 points. Usually one of these will be a roller point, the other will be usually a pin joint. First thing we do is, step 1 is we need to write down the equilibrium conditions. First equilibrium condition is the total force, or our resultant force is 0. The second equilibrium condition is that the total moment about a point is equal to 0. So looking at this, I'm going to write an expression for our forces. The easy way to do this is to look at the forces that are acting upwards, add those together, RA, RB, and then look at the forces acting downwards, take those away. So -3 minus 6 is equal to 0. This gives us an expression that links the reaction at A plus the reaction at B equal to some amount of force. Here it's 9 newtons. The second step we need to do is write down our equilibrium conditions. So we pick a pivot, pick a point to be our pivot. Usually this is one of our supports, so either A or B. So let's choose, for example, A. So moments about point A, the total moment is going to be 0. So that means we need to find our anti-clockwise and our clockwise moments. The anti-clockwise moments is going to be caused by any forces that making this beam rotate upwards this way. So that is going to be the reaction at B, and that is acting at 10 meters away. Then we take away the clockwise moments. Now, looking at A, if we put our pivot at A, the reaction at A goes straight through the pivot. Even though it's got a force, it's not got a moment because its distance from the pivot is 0, and moment is force times distance. Times alt by 0, you get 0. So we're going to look at the ones that have got a distance to them. We've got 3 newtons acting at 1 meter, and we've got a 6 newtons, which is at a clockwise moment, acting at 6 plus 1, which is 7 meters. And we know the total of that is 0. Then all we do is we simplify this down. So take away 3, take away 42 is equal to 0. So that gives us that 10 lots of the reaction at B is equal to 45 newtons, which means the reaction at B is equal to 4.5 newtons. Then our last step is going to be, so this is step 2, consider your moments, and step 3 is to solve for the missing reaction. So if you picked your B to be your pivot, you would have found A by looking at your moments. With us choosing A to be our pivot, we found the size of reaction B. We just need to find the reaction A, and we've got ourselves a useful expression for that. RA plus RB is equal to 9 newtons. So that means that RA is going to be 9, take away 4.5. So reaction A is 4.5 newtons.